Okay, so today we're looking at the modulus and argument of a complex number. Okay, so now the other day we talked about complex numbers. So the real part might be x and the imaginary part is iy. So you have your complex number here, which is x plus iy. Now, so let's say I were to draw a line joining from the origin to this complex number. Now the distance, let's call it r, and the angle that this line makes with the x-axis, let's call that theta. Okay, so now this distance from the origin to the complex number is what we call the modulus. Okay, so modulus, it's the distance from x-axis, distance from the origin to the complex number. Now, there is a notation for it, and it is these lines here. And you may have been familiar with them by, you might have been calling them absolute values, okay? So x plus iy, the modulus of x plus iy. So if you have a look at the diagram, you can see that this is a right angle triangle. This distance is x and this distance is y. So I can work out the modulus by using Pythagoras, x squared plus y squared. There's no I, just the distance. We're talking about the distance. So that would give us the modulus. Now, the angle. Again, if you look at this, you've got the opposite and you've got the adjacent. So we're going to use tan. Oh, let me talk about the argument first. So argument, it's the angle the line joining the origin and the complex number make with the x-axis, okay? Oops. Oops, oops, oops. Now, how do we work it out? So we have the opposite and we have the adjacent, so we're going to use tan. So theta is going to be tan inverse of y over x. Okay, now there are some situations where you have to make some adjustments. It's not just theta is tan inverse of y over x, and let's look at those situations now. Oops. Okay, so let's say you have a complex number which is -3 plus 4i. Now, if you have your calculator, you can try and do this. So, by the way, I should mention the angle is always in from the x-axis. So this is the angle I'm looking for. So now I can try and show you on my calculator. Let's see if that works. Okay, so I am doing tan inverse of y over x. So our y was 4 and our x was -3. So I've got an angle of -53.13. Now, if we go back to our thing here, so -53 does not seem correct. So by the way, we should, I'm not sure if we've mentioned this already, but so the angle that's going in this direction, okay, so the anti-clockwise is positive, and the angle going in the clockwise direction is negative, okay? So this one that we got was negative 53, so which is here somewhere. So that's the angle that we've been given. What was the negative 53.13? But that's not the angle we want. We want the other angle. So the way to work it out is, if you can imagine, so it's actually 180-degree turn. So I'm trying to go the other way. So I'm just going to add 180 to negative 53.13, and that will give me my angle. So this is always the case if you are in this quadrant. Okay, so in this quadrant, whatever you get on your calculator, you add 180 to it. And if you were working in radians, you add pi to it. Okay, but now let's look at this quadrant. Now, I should say same as calculator answer in this quadrant, and same here, same as calculator answer in this quadrant. So in these two quadrants, there's no change, but on the left-hand side, you will have to change. So now let's look at one where it's negative 3 and negative 4i. So I've got something here, negative 3 and negative 4i. So let's look at our calculator and see what it says. So our y is negative 4 and our x is negative 3. Okay, and it gave me 53.13. So if I go back, so it gave me an angle which is over here. Okay, but that's not what I want. What I want is this one here. Now I am just gonna because it's in the negative direction. Now that's another thing I should mention to you. We have something called a principal argument form. We always try and give our angle within this range. So angle, so the angle is always between 180 and negative 180. Or if you're working in pi, it is going to be between pi and negative pi. So we always try and give the answer in these in this range. So what we are, if I add on 180, okay, it's not going to give me what I want. But if I take away 180, it will end up giving me the right one. So if you're in this, quadrant, whatever you get in your calculator answer, you take away 180 or take away pi, depending on which mode you're working in. Okay, so I think if you have a little piece of paper, write this in somewhere. I know it would be hard to constantly go back to the video, so just draw this in, that in the top quadrant and the bottom quadrant on the right hand side, whatever you get in your calculator is the answer. But if you're on the left hand side, so in the top quadrant, you add 180 or pi, and in the bottom left, you're going to take away 180 or take away pi. So we just had 53.13. So I'm going to take away, so 53.13, take away 180. And here I have negative 126.87. That's not what we want. Okay, so what I want you to understand also is anti-clockwise is positive, clockwise is negative. I know this seems kind of counterintuitive, but that's usually the case. So clockwise is negative, anti-clockwise is positive. Okay, so now those are the two things just to kind of remind ourselves again. Modulus is the distance from the origin. We use Pythagoras to work it out. Argument is the angle the line makes with x-axis, and we are using tan inverse of y over x. Now, the next thing is something called the modulus argument form, or it's called the polar form. So let me just write that down for you. And some people even call it the trig form. So what it means is, what is wrong? Okay, so what it means is, let's go back to that diagram we just had. So if you have a complex number, x plus iy. Now, going back to when we did trig, remember this, if this is theta, and let's say that's r, the vertical distance, okay, is r sine theta. And the horizontal distance is r cos theta. So it's just using trig ratios. Sine theta is opposite over hypotenuse. Okay, so you've got sine theta equals y over r, and cos theta equals x over r. And rearranging them, you get r equals y sine theta. And here, sorry, that's not what I meant. So rearranging them, you get y equals r sine theta and x equals r cos theta. So y is r sine theta. So I've got, instead of y, r sine theta, and let's not forget the I. And for x, it's, okay, that's not here. So I hope you're okay with it. X plus iy is the same as r cos theta plus I r sine theta. Okay, so now the next thing is, there's a common factor of r in both of them. So I'm going to take out the r, and I've got cos theta plus I sine theta. So this is another way of expressing x plus iy. But then, you know, we in maths, we always try and shorten things. We don't like to write these long bits and pieces all the time. So this is very important. I hope you're paying attention. So to shorten it, instead of writing cos theta plus I sine theta, we abbreviate it and write it like this. Okay, so r cis theta. Now, it's very important that you understand this is an abbreviation. It's not like cos or sine or tan. It is an abbreviation. So every time you have to work out, let's say, r cis 25, I mean 5 cis 25, you're not going to be looking for cis on your calculator. You have to do r cos 25 plus I sine 25. So that's what you need to understand. It's just shortening it because we're lazy and we don't want to write it out all the time. Okay, so now let's say I had to write write 3 plus 4i in polar form. Okay, so always sketch, so because it gives you an idea of what the angle should be. So this is the angle we're looking at, and that's the distance. So the first thing you want to do is work out the modulus. So 3 plus 4 I modulus is 3 squared plus 4 squared square rooted. So that gives you 5. So our r is 5. Now theta, the argument of 3 plus 4i. Now remember, in this quadrant, we do nothing. We just leave it as it is. So it's just going to be tan inverse of y, which is 4, over x, which is 3. Okay, so I'm going to quickly put that into my calculator. It's 53.13, I know that, so. Okay, so what I do when I write it down, it's going to be 5 cis 53.13. Okay, so this is the polar form. Now, if I was going the other way, so if someone said to me now, write 5 cis 53.13 in rectangular form. So rectangular form is the one where you have x plus iy. Okay, so how do you do this? You write down the full form, 5 cos 53.13 plus I sine 53.13. Okay, you work it out, multiply it out, and simplify it. So we can do that now. Cos 53.13 is 0.6, and I'm timesing it by 5. So it's giving me 3. Oops, that's not what we want. And here, sine 53.13. Okay, and then I'm going to times it by the radius again, which is 5, which gives me something close to 4. Okay, so there we are. You can see now you've gone back. Of course, there was a bit of rounding, and that's why I didn't get exact values. But you can see how I can go back to rectangular form. So that is all for today. So just to summarize, what is the modulus? It's the radius, or the distance from the origin to the complex number. The argument is the angle, okay? And we just do tan inverse of y over x, but just be aware if you're in the quadrants on the left, you have to make an adjustment because our calculator only gives you the answer between 90 and negative 90. Okay, so yeah, and then if you want to know about the polar form, it's going to be r cis theta. That's how we write it. We're just using the angle that we work out and then the modulus, and you're going to write it this way. So that's that. Do we have any questions?